Assalamualaikum and good evening to Haikal. My name is Harid. I am a pharmaceutical technology student. I am a student year 3. So today what we're going to learn is thin layer chromatography. So can you introduce yourself a bit, Mr. Haikal?
Hi, my name is Haikal. Currently, I'm working as a nurse in private medical center in Subang Jaya, in Petaling Jaya, and I've been a nurse for 5 years now, and I'm more specific into oncology.
Okay, thank you, Haikal. So now we going to look what is thin layer chromatography. What is thin layer chromatography, or we call as TLC? Um, It is a technique used to identify compounds and to determine their purity of mixture. Um, we need to know what is so it means that we need to know what is this particular compound and what is the polarity uh, and what can it be used to separate. It can be used to separate many different mixtures, which is means to identify the compounds in the particular mixture. Okay, so it is also achieved and widely used in pharmaceutical and food industry. Uh, it is only involved in qualitative analysis, which is the results will be only involved in numbers, data, and measurement. There are two types, qualitative and quantitative, but in TLC, we only use qualitative. The result will come out with numbers, data, and measurement. Okay. So next slide is the stationary phase. In stationary phase, the wait, the TLC plate is made of aluminum glass. Okay. Um, means it have already the means that the plate coated have 0.3 millimeter thickness, and some of it added by fluorescence during light UV exposure. Means it the TLC plate have already coated with the fluorescence, and the silica used is used as the stationary phase. There are type of silica gel which is silica gel G25, and cellulose, and then the sample separation is depends on the polarity of the sample. Uh, this is the place where in stationary phase, this is the place where the separation of mixture occurs, and we can see the polarity of the sample. We can identify the polarity of the sample. Next, we will look into the mobile phase. So in the mobile phase, uh, the mobile phase will go up on the plate depending on the sample polarity. The the mobile phase will travel on the TLC plate. TLC plate, just I said before, is the stationary phase, right? So the mobile phase will go travel in on the TLC plate because uh because mobile phase is a liquid, so it will travel on the plate and depends on the sample polarity itself. And then we usually use volatile organic solvents, and the more polar the solvent, the further it will move a polar compound up on silica gel plate. Uh, it means that when we use mobile phase, a polar mobile phase, and the mixture used have the polar compound in it. So it will travel further away from the mobile phase because the sample is polar. So it will move further from the mobile phase. Okay. So the mobile phase is made to C particular drug will have different retention factor, which is RF value in a system. Retention factor is the distance traveled by uh, the solvent, which is the mobile phase, and the distance traveled by the sample. Okay, so there are two type of TLC. So the first one is the reverse phase, and the second one is normal phase. So, in reverse phase, the stationary phase is non-polar, but in a mobile phase, it's a polar. Okay, so in normal phase, the stationary phase, which is the TLC plate, uh, they are polar, and for the mobile phase, they are non-polar. Basically, these two is opposite to each other, so it might be a bit confused. So usually we use reverse phase. We memorize the reverse phase. So next is this is the diagram of uh, TLC chromatography, and as you can see here, this is the chamber for TLC. The TLC plate will dip into the mobile phase, and you can see the spotting line. The spotting line we use pencil to draw, and we plot the standard and the sample on the TLC plate using the pencil, and then the mobile phase will travel along the TLC plate. It will travel until the solvent front, which is here, and then we can identify the compound, identify the mixture with the standard. Okay. Okay. So here, we will look into the method. I have I will share the video. This is the video. Okay. Chromatography. So, what one? Okay, this is the sample, and then this is the compound. Compound A, compound B, compound C. Each of the compound and the sample we place on the TLC plate, drop per drop. This is the sample. first drop, and then compound A, compound B, compound C. Then after that, we will dip this TLC plate into the mobile phase, which is the solvent, and then so as you can see here, this is the affinity towards the stationary phase, affinity towards the mobile phase. Okay, so in this case, the more the compound travel, the further the compound travel to on the TLC plate, the more it is non-polar. This is the formula for retention factor, which is distance traveled by the component, which is the mixture travel into the distance traveled by the mixture, and then divide by distance traveled by the solvent, which is the mobile phase. So by the formula, the retention factor formula, we can know the compound presents for the mixture based on the sample. Okay, so now we will look into the advantages. Okay, so first one is in TLC, it is very cheap to use because it's not involving too much apparatus and machine. And then it is easy, it is simple because easy to install or run it. And the third one is the process can be seen by naked eyes because You can see my previous slide, the work done manually and not using any machine. The result also can be seen easily using our own eyes. And the last one is able to use various chemicals as detectors. Okay, that's all from me. Any questions?
Based on your presentation, I have one question regarding your mobile phase and reverse phase. I want to know what is the function, and could you explain more about the function of mobile phase and reverse phase?
Okay, so I will explain about the mobile phase. The mobile phase and the mobile phase, the mobile phase and the reverse phase is mobile phase is the solvent, which is this one. Mobile phase is the solvent used to travel on the TLC plate. Okay, when the mobile phase is polar, it will move. It will when the mobile phase is non-polar, it will move the mixture more further from the mobile phase. Okay. Um, for example, when we use a polar mobile phase, the mixture who have which has polar which is polar will move further towards the mobile phase. Move further on the TLC plate, and for the if the mobile phase is used non-polar, same with if mobile phase used non-polar it will move further away the non-polar mixture. Okay, okay, that's all from me.
Okay, thank
Thank
you.
you. Can you please evaluate me? You need to scan this QR code.
Okay. Okay, I'm done.
You're done? Okay, thank you. Thank you so much for spending your time.